that you have in these slots. You have pointer fills, like a succession organization, which essentially just have an ID for another template, which has its own set of slots. You have string fills, like CEO, where you're essentially pulling it out of a text. So that's the post slot. And then you have these slots like reassignment that are called set fills. So you have a pre-specified finite set of values that can go in one of those slots, and you have to pick the right one. So here we have essentially events which are centered around organizations and posts, and then point to one or more in and out templates that are centered around a person and the direction that they're moving in. Are they leaving or coming into the job? And then you have various other types of slots. But this requires that you pull information from different parts of the text and represent it together. So in one place they say Star TV, and that's the real name. In another place they refer to it as Star, so we call that an alias. Another place they call it the satellite broadcaster, so that's what's called a descriptor. Type is just a slot set fill. Here again we have names and the aliases for people, and we even keep track of their titles. So these systems are evaluated in a two-step process that interleaves an alignment procedure with a scoring procedure. So essentially, you may have many events represented in an answer key for a document, and your system generates many events. So the first question is, what event descriptions that the system generates correspond to what event descriptions in the key? This isn't necessarily a trivial question, because there's no slot that could uniquely identify an event. So that's the alignment question. So the question is, what templates are possible, are candidates for alignment? And the community deliberately chose a very weak alignment criteria, just saying if two templates share at one slot value, no matter what slot, that's a candidate for alignment. Beyond that, then you do a search where you score that alignment and then try to search among different alignments, essentially in a greedy fashion, trying to find the alignment that maximizes the score. And because it's essentially a greedy process, an optimal solution isn't guaranteed, but we kind of expect one because while graph matching isn't an NP-complete problem, these graphs aren't that large. The actual metric is being used as well, first we borrow from information retrieval the notions of precision and recall, in this case on slot, measured at the slot level. So the precision is the percentage of slot values that the system creates that are correct, that is, that are in the key, and recall